Right then, so this is question number 15 of the nuclear physics homework booklet, and in question 15A part 1 we're simply asked to write down what is meant by the random nature of radioactive decay. So random basically means it's not possible to tell which nucleus will decay or when it will decay. It's purely chance, really. So what you really need to say is this part here and then finish it off with the chance part. In part 2 we're then asked to explain what's meant by each of these. So an isotope. So isotopes are, and basically all three of these things you can just learn. So isotopes are different forms of the same element. They have the same number of protons but different number of neutrons. Radioactive half-life, it's the mean time for the number of nuclei to halve for a particular isotope, or it's the mean time for the activity to halve. And the radioactive decay constant is simply the probability of decay per unit time. So that was worth 6 marks altogether. So you got 1 mark for the first part, you got 2 marks for this part, you got 2 marks for this part, and 1 mark for that part. In part B, we're then told that the radioactive isotope of iodine, so iodine 131, has got a half-life of 8.04 days. And we're asked to calculate the decay constant. So the decay constant is simply equal to the natural log of 2 over the half-life. So what we could do is simply put our number from the question straight into here, and it gives us 0.0862 per day. So that would really do, but just to make sure, because it doesn't say in the question, I'm just converting that into seconds. So the way that we convert that into seconds is basically by taking this and dividing by the number of seconds that are in a day. And if we do that, we basically get 1.0 times 10 to the minus 6 per second. To be honest, if I was going to do this right from scratch, I think what I would do is I'd convert the half-life into seconds and then I'd do the calculation. It'd give me the same answer, but potentially it's easier than trying to convert per seconds into, per days into per seconds. In part 2, we're then told that the number of these iodine atoms that has to produce a sample with an activity of this, and that's what we're asked to work out. So we're asked to work out the number of atoms that will give us this activity. Now if we're asked to work out the number of atoms and we know activity, this is the equation we would use. So that's the activity, it's equal to the decay constant times by the number of nuclei. Now this only works if the decay constant is in per seconds. So if in this question we'd have left it in per days, we would have had to convert it into per seconds anyway. So the activity, which is measured in becquerel, is equal to the decay constant in per seconds multiplied by the number of atoms or nuclei that we've got. So if we rearrange this into this equation, just put our numbers in, so that's the activity, that's the decay constant we worked out, gives us a number of atoms of 5.0 times 10 to the 10. And then in part 3, we're asked to calculate the time taken in hours this time for the activity of this sample to fall from 5.4 times 10 to the 4 disintegrations per second, so that's an activity, to 5.0 times 10 to the 4 disintegrations per second. So the activity is going from this number down to this number. So again, just like we've seen in the last couple of questions, we're going to use this exponential equation here. This is the activity basically now. This was our starting activity. So if we put these numbers in, this was the starting activity up here. It went down to this activity here. So this is the A, the 5.0 times 10 to the 4. This is the starting activity, the 5.4 times 10 to the 4, is equal to e to the minus this number, t. So that was our decay constant in per seconds. So we're going to work out a value of t in seconds. So again, we rearrange this, we take natural logs of this thing, and in the end we end up with 76,961.04 etc. seconds. We want this in hours, so we divide the number of seconds by the number of by 60 times 60, because there are 60 seconds in a minute and 60 minutes in an hour, and that gives us 21 hours altogether. So altogether that was worth 6 marks, this part of the particular question. So you basically got 2 marks for this. So you got 1 mark for doing this part and 1 mark for this part. You got 1 mark for that, so that's 3 marks. You got 1 mark for using this equation correctly, 1 mark for basically rearranging it correctly, and 1 mark for the right answer. So that added up to 6 altogether. So that was question number 15 of the nuclear physics booklet.